El día de hoy tenemos un par de presentaciones. La primera va a correr a cargo de la doctora Zayre González y Citlali Jocelyn González Troncoso. Ellas van a hablar acerca de un método para evaluar impacto ambiental y el desarrollo sustentable en un proyecto de geotermia. Después tendremos a Luis Hernández, estudiante de la MAIA, con la factibilidad del uso de la energía eólica en México. I would like to give a brief announcement. This is going to be my last time here leading this, welcome you being a host, because I have stopped being the manager of MAIA. From now on, the doctor, he's not here, yeah, he's here. Carlos Vázquez, he's going to be your new host. This doesn't mean that we are not going to continue at all. On the contrary, we are open here for your visits to keep this going. This initiative belongs to students, and we believe and we hope that it's going to continue for a long time to come. Well, as well, we have here the director of postgraduate students there. Welcome is Dr. Araceli Almaraz. She's our boss. Welcome, Araceli. Aquí lo que estaba diciendo para nuestras personas, que las personas que nos están siguiendo por el internet, es que esta va a ser la última sesión en que voy a hacer, estar hospedando, recibiendo a este foro, porque he cesado desde hace una semana ser la coordinadora de la maestría en Administración Integral del Ambiente. De ahora en adelante el doctor Carlos Vázquez será quien esté aquí hospedando este tipo de evento. Y agradecemos también la presencia de la doctora Araceli Almaraz, directora de estudios de la Dirección General de Docencia. Okay, and after that, I promise that it will be brief. It is not. Okay, we have here Van Overmeyer. Yeah, thank you. Who is going to say some words, please?
Hi, my name is Ben, and I won't say my last name again. I think Kyle was better because his name was much more pronounceable. But I'm here. I'm one of the coordinators for IFER, the Interdisciplinary Forum for Environmental Change, and for more than 1 year now, going into our second year, we've been so lucky to cooperate with Colef on this venture of exploring the questions of environmental change. And every time that we've crossed the border, we've counted on such a warm welcome. And we just like to extend our gratitude to you for hosting us so nicely in your own country. And the gratitude especially goes to Gabriela, who, as she just announced, is stepping down. We've found in her an amazing partner to work with, and we hope that with Carlos we can continue this cooperation in the future. As we go into next quarter, spring quarter, we'll continue to have events at UCSD, and some of you have already attended those. We hope that you will continue to come, because we need you, we need your voices in that room as we examine this fundamentally important question of climate change. So, yeah, thank you so much.
Okay. Sin más, entonces, ¿estás lista, doctor? Okay. Jocelyn empieza. Okay. Then, Jocelyn, please go ahead. Yeah, I do beg your pardon. I'm so emotional this time that I forgot to present our speaker. Dr. Gonzalez is a chemical engineer with a specialty on Environmental Technological Institute of Toluca, and that is in central Mexico. She has a master on chemical engineering in process integration by the from the University of Guanajuato, and a PhD in environmental geochemistry by the University of Heidelberg in Germany. Work in the National Institute of Nuclear Research, Environmental Science Management, and since 2012 working at CICESE, at the Division of Earth Science of the geology department, especially on the environmental geoscience, the postgraduate program. We are really happy that she had accepted to present now. She's a close collaborator of MAIA. Thank you for being here. Go ahead, Joseph.
Hi, good afternoon. It's a pleasure your visit in our school. Welcome to the Colef, and we are start talking about the presentation. We will show to you the presentation in 4 principal parts, and the first one is the introduction, the methodology, and the results, and the conclusions. The topic is use of rapid impact assessment metrics to evaluate the environmental impact and type of sustainable development in a geothermal-electrical project. Okay. This is the content, the introduction. I'm going to talking about this part, and after the Dr. Zayre, she will talk about the methodology, the results, and the conclusions. In this slide, you can see the Chichonal, Mexico, and the Jersey. Okay, thank you. The Chichonal is a volcano located in Chiapas, in the southeast in our country, and is one of the 20 potential locations for developing a geothermal project. And the Jersey Valley is an example for geothermal plants in USA. Well, the geothermal energy is the word is coming from the Greek words geo, the meaning is earth, and therm, the meaning is it, and the geothermal, and therefore the geothermal energy is heat from inside in the earth. It's a renewable energy source because the heat is continuously produced inside the earth. And the geothermal reservoirs are naturally occurring areas on hydrothermal resource. They are deep underground and are largely undetectable above ground. And you can see this image. This is the Ring of Fire. This is an area where is localized the tectonic plaques. The plate tectonics is a large number of volcanoes and headworks. In all this place is around the Pacific Ocean and in the countries, the American continent, and the Asia and the Australia. The electricity generation from geothermal energy, we can find the way of the Earth surface in 3 ways. And the first one is the volcanoes and fumaroles, that is the holes where volcanic gases are released. And the second one is hot spring, and the third one is the geysers. And the geothermal energy is stored in rock and in trapped vapor or liquids, such as water or brines. This geothermal resource can be used for generating electricity or for providing heat or another use. The electricity generation usually requires a geothermal resource with temperatures over 100 Celsius degrees. The importance in the world of the geothermal is considered because according to the International Energy Agency, in 2012, the global geothermal power capacity was 11.4 gigawatts and generate about 72 terawatts per hour of electricity. We can see these charts, and this describes the production of geothermal electricity, and we can find the United States in the first place, and the Mexico is in the number 4. And for this part is different. This is the direct use for geothermal, and if you remember, I was talking about the different use of geothermal, and for example, China used the geothermal for direct use and no properly for electricity production. Is a difference with this part of the chart. The importance in Mexico. In the case of Mexico, the geothermal energy is a source for electricity power, supply water systems in the industry, buildings, agriculture, for recreation, and even used for medicinal purpose. We use for a different kinds of uses. For principal is the electricity power. And in 2023, the virtual all electricity generation from renewable resource focus on geothermal with find the 23% according the Ministry of Energy. And in this chart, we can see the plants, the different plants of geothermal electricity in Mexico. We can find the Cerro Prieto, localized in Mexicali, Las Tres Vírgenes, localized in Baja California Sur, Los Azufres in Michoacán, and Los Humeros in Michoacán in the middle in Mexico. And since 1973, we start with the plants, geothermal electrical plants with Cerro Prieto, then generation, the generator 1, and after the other ones, and the last one is the Tres Vírgenes. We can localize the different plants. This is Cerro Prieto, this is Tres Vírgenes, Los Azufres, y Humeros. You can see this is the potential geothermal zone in our country, and Cerro Prieto is the first one in the for the production in our country. The generation for electricity from renewable energy, we can find the geothermal in the second place behind the hydraulic, and the principal generator is the Parastatal Electricity Federal Commission, and the actors private is not appear here, and we can find this scenario different in the next years, because recently we have the new law of geothermal, of energy geothermal, is approved recently, and the potential of generation electric for renewable energy is in three terms. This is the probably, the proven, the probably, and the possible. And we can see the potential in this energy. In this map, this is a study by one of the best experts in the field. The name is, the surname is Hilliard, and we can find them 20 locations with a major potential of geothermal energy. Between the advantage and disadvantage, we can find different points. The geothermal energy is already considered an export, both economically and technically. This is clean, flexible, reliable, and plentiful resource with the potential to be used in a wide variety of application. And for example, the positive characteristics of this energy include the capability to provide base load power, no seasonal variation, immunity for weather effects and climate change impacts, compatibility with both centralized and distributed energy generation, resource availability in all world regions, particularly for direct use, and the barriers is another ones. Include the high capital cost, is a resource development risk, and the lack of awareness about geothermal energy, and perceived environmental issues. Some of environmental impacts during the development of geothermal energy projects are the gases in the atmosphere, the liquid waste, the solid waste, the noise, the visual impairment landscape, the subsidence and seismicity, and in general terms, we can find advantage and disadvantage in this part. The noise, the visual impairment landscape, the subsidence and the seismicity. And this is the part of introduction, and now I'm going to talking about the RIAM. The RIAM is an instrument of valuation of the environment impacts in all dimensions, like social, ecology, economy, and the RIAM is a rapid impact assessment matrix. It's based on a standard definition of the important assessment criteria using semi-quantitative values to provide an accurate and independent score for each condition. During the geothermal projects, the impacts are evaluated against the environmental components, and for each component you can put a score, and this is determined with provides a measure of the impact expected from the component. And the RIAM considered three principal points, and of the sustainable development, like the best ways for get this.
No, sí.
Okay.
Can you hear me or not? Because the internet. Sorry, because I like to speak on my feet.
It's for the people in
Okay.
Chiapas that are following us.
Yeah, I cannot stay sitting, just explaining. So I will stay by my feet. So I hope you have a broad introduction and about an idea of geothermal energy. As you can see, it is considered a renewable energy. However, it's not that clean as normally we think. Of course, if you compare with the hydrocarbons, production of energy, normally most of the renewable energies or alternative energies are clean or are cleaner. But in the case of geothermics or geothermal energy, it's not as clean as we can think about. But right now, we are going to talk about the sustainable development. The sustainable development normally it's including the social, the economic, and the environmental aspects. And the theory says that if you have an equilibrium between social and economic, then you have a fair project. If you have an equilibrium between economic and environmental, then it's feasible. And if you have social and environmental equilibrium, then it's livable. And if all three are in equilibrium, then we have the sustainable development. Yes, so based on this definition, sustainability in terms of geothermal energy means the ability of the production system to sustain production levels over long periods. It has to be at least hundreds of years. And to be able to do this, then you have to consider that the geothermal resource, the extraction never should exceed the natural recharge of water in the aquifer. I think there is historically, yeah.
Wouldn't it be possible to pump the water back down? Or
It
that
is
typically what you do? Or?
not typically, but is now coming.
Okay. Why would you not do it? What is the reason not to do it?
Because if you have the heat and then you reinject the water inside the system, then the water comes with a lower temperature. So your system slows down. Yeah? And then you don't have the production of energy as you normally have. So it becomes cooler. So that's one of the issues. Okay? Then methodology. Why we would like to make like a rapid environmental impact assessment? Because as you saw, we have many different impacts from this kind of energy. Then we used a semi-quantitative assessment for each criteria, providing an accurate and independent score for each condition. Then we have the A1, which is the importance of condition, and it is evaluated in this scale. We have 4 when it is important to national or international interest, 3 if it's important just regional or national interest, 2 if it's important to areas immediately outside to the local condition, 1 if it's only local, and 0 if it's of no importance at all. Then we have the A2. This is the magnitude of charge or effect. And we have +3 if it's a major positive benefit, +2 if it is significant improvement in the but what is the meaning of poor? Is the initial status? No? Yeah. That's the word I was looking for. Okay. And +1 if it is an improvement in this status, 0 if there is no change, 1 if it is negative change, 2 if it is significant negative, and 3 if it is a major disbenefit or change. Okay? Then we have the B's. The big one is the permanence, which is evaluated with this scale. 1 if it is not change, 2 if the change is temporary, 3 if it is permanent. And then we have, okay, B2, which is feasibility. 1 if there is no change, 2 if it is reversible, and 3 if it is irreversible. And B3 is a cumulative. It should be not confused with a permanent or irreversible situation. It is just cumulative within the years. So 1 if there is no change, 2 if it is not cumulative, and 3 if it is cumulative or synergist. Then we have these equations. We multiplied A1 by A2, and we have this factor, AT, and we summarize B1, B2, and B3, and we get this BT. And if we multiply it both, then we have the overall environmental score. Yeah. So this is the methodology of the RIAM, the matrix. And then we have the components, which are physico-chemical components. This covers all physical and chemical aspects of the environment, including finite, non-biological, natural resources, and degradation of the physical environment by pollution. Then we have the biological, ecological. This covers all biological aspects of the environment, including renewal, natural resources, conservation of biodiversity, species interactions, and pollution of the biosphere. Then we have sociological and cultural. This covers all human aspects of the environment, including social issues affecting individuals and communities, together with cultural aspects, including conservation of heritage and human development. And finally, we have the economic operational aspects. These 6 identify qualitatively the economic consequences of environmental change, both temporary and permanent, as well as the complexities of the project management within the context of the project activities. So as you saw, we have all these A and B components, and then we have also the environmental components. And this includes also the social, cultural, and the economics and operational. And after that, you can apply it. You have here the environmental score and the range bands, and this is the description of the range band. Then you get a score, and then you can put it in a band, and this will be the description of this band. Yeah. So we have major positive changes up to major negative changes, and in between we have significant, moderately positive, slightly, and no changes. Then how to evaluate sustainable development? Okay, I would like to say that this methodology was proposed in 1998 by Pastakia, and then in 2010, an English PhD student modified this matrix, and he added this evaluation of the sustainable development. So we have the E, which is equal to the summatory of the physico-chemical aspects, plus the summatory of the biological, ecological aspects. And then we have this, the PC max and the BE max. And then we have HN1, which is the social part, the social aspects and the economical, operational aspects. And then from there, you get this S, which is these ones minus these ones. And from there, if E is measured to HN1, then S is measured to 0, and the system is sustainable. And then you can say, because obviously it's in equilibrium, all the aspects. And then you can evaluate and say if the sustainability is very strong or weak or very weak, according to the numbers you get. And then if E is lower than HN1, then S is lower than 0, and the system is not sustainable. Okay? Then after that, we try to apply this matrix to a real case of study, which is Cerro Prieto, which is also the oldest geothermal power field in Mexico, and is the hugest and the most important. Then Cerro Prieto is located here in the north part of Mexico, in Baja California, and very close to the border to the US. It is a geothermal field located in Mexicali Valley at the Mexican northwestern, yeah, that's right, state of Baja. No, but it's northeastern of the state. Okay? Yeah, don't confuse me. It's northeastern of the state of Baja California. It is 30 kilometers south of the border with the United States. Cerro Prieto is a large high temperature. As Jocelyn told you, you need at least 100 Celsius degrees to be able to produce electricity. Obviously, if you have more temperature, then it's better. So 300 degrees is like a mine of gold, in geothermally speaking. Then this field is liquid-dominated field contained in sedimentary rocks. Cerro Prieto began commercial operations in 1973, and in 2000 had 3 power plants with 9 operating units. 5 minutes? Okay. In the about 15 square kilometers area that is under exploitation, more than 300 deep wells. That means that we have 1,250 to 3,000 meters depth in each geothermal well. And this field operates by the Federal Commission of Electricity, which has divided the field in 4 zones, and they wanted to put the number 5 here. So those small black dots are the geothermal wells, and we have the unit 1, 2, and 3, and 4, and they wanted to open the number 5. But the actual capacity of Cerro Prieto geothermal field is 550 megawatts, because the units 1 and 4 are out of service since 2011. So this is more or less the summary of the environmental impacts, and from here we tried to choose our environmental impacts, like the physico-chemical and ecological and socio-cultural, etc. So, results. We chose odors because of the hydrogen sulfide, the gas emissions, speaking about methane and CO2 and others, the groundwater quality, surface water quality, air quality, the winds, also the solid wastes, the geothermal fluids, noise, soil quality, impacts of increased industrial activity. Okay, I will be faster on this, and we can discuss later on if you have more questions. And the biological and ecological components are the impacts on biota, damage of habitats, and anti-aesthetic impact and dumping of the industry. And then we have in the sociological and cultural components, public acceptance, culture, education, migration, recreational areas, work opportunities, public health, impact on housing, population growth, public safety, and in the economical and operational components, the works, public services, tourism, agriculture, operation and maintenance, recycling, traffic, loss of property value, and cost of community health because of the emissions. No. And this is the result of the all summatories of the whole components, and the E and the H in one and the is, and it is not sustainable. Okay. Oops. So, what is the scope and limitations of the RIAM? The RIAM of Pastakia is limited since there is no numerical results. This is just the A and the B's. And you have numerical results, but you cannot compare, like, you don't know if it is sustainable or not, or only a limited set of parameters can be managed in the RIAM. Like you saw the public health, it has different factors, and you just evaluate public health. Okay, and the scale factor has different, I won't say weight, but different ponderation. And both RIAM matrix do not integrate mitigation measurements into their frameworks. So this is like. So finally, two conclusions, rapid ones. The result of the first approach of the rapid environmental assessment of the geothermal power plant of Cerro Prieto, Mexico, revealed that the system is not sustainable given the negative environmental impacts. Therefore, it is important and suitable that additional research is conducted in order to elucidate more data on the environmental aspects related to geothermal power production and the prevailing sustainable development considerations. The RIAM is a very helpful tool. However, the generality of the evaluation criteria makes it questionable in order to identify the direct responsible of the negative or positive impacts, because this is just the criteria of the persons. Thank you.
Thank you very much, Jocelyn. Thank you very much, Doctor. I don't know if you have an question that cannot wait, or can we continue? Do you want to ask something at this point, or?
After this second presentation, we have a couple of minutes for just discussion related to both presentations. So let's carry on with the next presentation, and then at the end, some discussion, right?
Yeah. Okay. I have plenty of questions. But okay. I forgot to present Jocelyn. Jocelyn is a student from MAIA, and she used to work at the Secretary of Energy. So if you have really uneasy questions regarding the operation of the environment, of the energy system in Mexico, you can direct her questions to her. Okay, and our next speaker is Luis Garcia, and he's going to talk about feasibility of using grid power in Mexico. He is a biologist by training, so are you ready? And you are going to give your presentation in Spanish, isn't it? Okay, sorry guys, hope, go slowly please so they can understand, and if you don't understand, we are going to ask them to repeat everything in English. Okay, thank you. Go ahead.
Hola, buenas tardes. Bueno, mi presentación va a ser en español, pero para que tengan idea de lo que les estoy hablando, pues también puse ahí unos subtítulos en inglés. Así que bueno, el tema es viabilidad de la utilización de la energía eólica en México. Y bueno, esto es para la generación de electricidad, enfocado en la generación de electricidad. El contenido de la presentación es, bueno, primero les voy a hablar de la energía eólica. cómo se genera, su ciclo, la energía del viento como fuente limpia de energía, la generación de la electricidad a partir del viento, el potencial que tiene aquí el país, México, para aprovechar el aire ahora sí como fuente de energía. Y voy a hablarles un poco de la legislación, sí, de manera muy general, y sobre los retos que implica la utilización de la energía eólica aquí en nuestro país. Bueno, primeramente, hacia grandes rasgos, les explicaré qué es la energía eólica o cómo se genera. Y bueno, la energía del viento es un recurso que se genera a partir de la energía solar. La Tierra recibe más energía del Sol en el Ecuador. Esta hace que se caliente la atmósfera, y el calentamiento diferencial entre la Tierra y la atmósfera hace que se cree un ciclo, que es lo que conocemos como el viento. Bueno, algo que ya se discutió en la presentación también pasada es que pues estas energías desafortunadamente pues no son ahora sí que 100% seguras. O sea, su característica es que van a depender de otros factores. Bueno, en el caso de la energía eólica, su variabilidad depende tanto del espacio como del tiempo. Y entre otros factores va a depender de la región climática, la topografía, la estación del año, la altitud, la vegetación local, entre otros factores. Bueno, y aquí hay un esquema, ¿sí? Pues bueno, esto es el aire frío, que es desplazado por el aire caliente. Los rayos del sol calientan lo que es la capa de la Tierra, la superficie de la Tierra y también el océano. Esto crea el flujo y esto se conoce como el viento, que es un ciclo. Bueno, después tenemos que la energía del viento es una fuente limpia de energía. Inicialmente, allá por hace dos siglos aproximadamente, en el año 1800 o hace 200 años más o menos, se empezó a usar la energía del viento para moler granos principalmente, o la generación de pinturas a partir de ahí algunas semillas y unas rocas. Bueno, y hay un ejemplo que es así como típico, que es el caso de Holanda, o emblemático más bien. Y bueno, también se han aprovechado en zonas rurales para extraer agua de los pozos. Y actualmente pues lo que está ahora sí como recibiendo más impulso es la generación de electricidad a partir de turbinas o aerogeneradores, que es una fuente que, como comentábamos hace rato en la discusión, es renovable y es limpia, porque pues, hay diferencias entre una fuente limpia de energía y una fuente renovable. Bueno, por ejemplo, el gas natural se considera limpio, pero no es un recurso renovable. Y bueno, aquí se puede observar la Rumorosa, que es aquí en Tecate, y donde fuimos a visitarlo. A ver, bueno. La generación de electricidad se da mediante la turbina eólica, que es una máquina que convierte la potencia del viento en electricidad, que es a partir del movimiento que genera la energía cinética del viento. Y bueno, estos generadores pueden formar parte de una red eléctrica y pues en ocasiones pueden estar aislados, o pueden estar conectados a la red eléctrica de la región o del municipio, por ejemplo. Bueno, ya entrando con la parte del potencial de aprovechamiento, son datos tomados de hace 2 años aproximadamente de una iniciativa que hay aquí en México llamada ProMéxico, donde se describen lo que son 5 regiones, que es el Istmo de Tehuantepec en Oaxaca, que es la principal, y es donde hay 1.248 megawatts en operación actualmente, bueno, con datos del 2013. La Rumorosa, aquí en Baja California, que ahorita hay proyectos que se están haciendo y que en total hay una capacidad instalada de 258 megawatts. La costa del Golfo de México, lo que es el estado de Tamaulipas y Veracruz principalmente, con 477 megawatts. Y la región norte y centro, que es el estado de Nuevo León, que cuenta con 274 megawatts, pero que se están previendo que se construyan más. Esto dice que a más tardar en 2014, o sea que ahorita ya está en funcionamiento. Y bueno, también está la península de Yucatán, que no tiene datos, pero que también tiene potencial. Y bueno, aquí les tengo un esquema que es tomado de ahí mismo. Son datos de la Asociación Mexicana de la Energía Eólica. Bueno, y son las zonas de las que les hablaba, lo que es Baja California, el centro norte, la parte del Golfo, la península de Yucatán y pues la que es la principal de aquí del país, que es Oaxaca. Bueno, en comparación con la iniciativa de la CENER, del Inventario Nacional de Energías Renovables, se puede ver que sí está que hay concordancia con estas otras regiones que ya se habían propuesto de la diapositiva anterior. Y bueno, esta iniciativa se puede consultar en internet. Este es un portal interactivo y donde en ese portal nosotros podemos no solamente ver lo que respecta a la energía eólica, también hay de geotermia, biomasa, solar y oceánica. Pero bueno, en este caso yo solamente estoy poniendo la energía eólica porque es la que se está tratando. Y bueno, continuando, tenemos que aquí en México recientemente hubo una reforma energética hace poco más de un año, y ya anteriormente había habido esfuerzos o se habían trabajado en materia de legislación, y de ahí tenemos que hay una ley general del cambio climático, hay una ley especial para el aprovechamiento sustentable de la energía y otra que es para el aprovechamiento de energías renovables y su financiamiento. Y recientemente se aprobó una ley de transición energética. Bueno, hacia grandes rasgos lo que promueven estas leyes, principalmente la del cambio climático y la del aprovechamiento de energías renovables, es que para el año 2025 se genere el 35%, si no me equivoco, de energía a partir de fuentes renovables. Inicialmente se planteó para el año 2012 que se alcanzara el 8%, pero según lo que consulté no se alcanzó el objetivo. Y bueno, también se discute que a veces muchas de estas iniciativas solamente quedan en el discurso y que realmente no se ven avances palpables. Entre los obstáculos se encuentra, bueno, principalmente que sí es cierto que se ha impulsado el sector, sí es cierto que se ha respaldado a la Comisión Reguladora de Energía, a la CENACE también, pero en realidad no se le está dando cierta independencia, o sea, son órganos todavía que están bajo la tutela de la CENER, de la Secretaría de Energía, y que a veces se supeditan a la presidencia, o sea que sí hay iniciativas por una parte, pero o no se están no están arrojando resultados así palpables. Y bueno, un caso del que les voy a hablar y que es el que tenemos aquí del que tenemos aquí en Tecate es la Rumorosa, que no tiene mucho que se inauguró. Pero antes les voy a hablar de los retos de la energía eólica. Y bueno, principalmente los dividí en lo que son ambientales y sociales, aunque creo que podemos abarcar más dimensiones. Bien, entre los principales está pues lo que es el impacto negativo en la avifauna, en la muerte de aves por colisión o por los cambios de presión en el aire, que es que también se han documentado en murciélagos, que es el barotraumatismo, sí, barotraumatismos, y que se deben principalmente a que chocan con las aspas de los aerogeneradores o a daño en el tejido por los cambios de presión. Y bueno, ese es uno como de los principales. Sin embargo, también existen otros, como es la alteración del paisaje, que pues bueno, no es tan palpable o puede ser subjetivo. Y los que creo que generan más conflictos son los sociales, porque los esquemas aquí en el país provoca que a veces, principalmente en comunidades ejidales, se susciten conflictos, principalmente por lo que es el alquiler de la tierra, y esto ha generado división entre comunidades y se han acentuado las desigualdades sociales. Esto está documentado principalmente en Oaxaca, que es un estado, bueno, que es el estado que tiene mayor potencial aquí en México. Y bueno, entre otros, se puede hablar de otras dimensiones también, como lo que es la geopolítica o retos en la economía. Pero ahorita estas tecnologías se han abaratado, o sea, por una parte sí es cierto que con la nueva reforma se está aspirando más a la parte tradicional, que son los hidrocarburos, se está impulsando su aprovechamiento, pero como ya se había discutido anteriormente en ciertas presentaciones, aún así, y dadas las metas que se establecen en las leyes, este sector está pues pujando también por ganar espacio en la generación de electricidad. Así que pues es un panorama que pinta un poco de esperanza, ¿no? Y bueno, estos son algunos... problemas técnicos, ¿no? Bueno, se supone que esto se reproduce. Bueno, el primero, el de en medio, es un ave que choca con las aspas de la turbina. Los otros son videos que muestran pues ciertas ahí percances en los aerogeneradores. Pero en general esto solamente es para ilustrar lo que les hablé sobre los impactos que tenía. Y pues bueno, que principalmente son en las dimensiones sociales y ambientales. Bueno, y ya para cerrar, les hablaré un poco sobre el proyecto de la Rumorosa 1 aquí en Tecate. Bueno, este proyecto cuenta con 10 megawatts de capacidad. Fue inaugurado en el año 2010. Esta generación de electricidad se destina principalmente al alumbrado público de Mexicali y tiene un esquema en el que en la que se beneficia a 35,000 familias. O sea, la propiedad, el proyecto le pertenece al gobierno del estado, al gobierno de Baja California. Sin embargo, es un proyecto que tiene un esquema diferente porque esta electricidad no se vende. Sí se vende, pero no para generar utilidades, sino más bien para subsidiar a familias de escasos recursos que no pagan todo su consumo de electricidad, sino que a partir de la electricidad que se genera en la Rumorosa 1, se les subsidia su consumo de electricidad. Digo, puede ser discutible o puede ser algo bueno, pero así es el esquema. Y bueno, aquí hay un video que, a ver si se reproduce también, que es sobre la construcción de este. Bueno, era sobre la construcción del parque La Rumorosa 1. Vamos a ver si se puede o si no.
Necesitaba haber puesto los videos, ¿no? Un hiperlink a los videos.
O sea...
¿No tienes video?
Sí lo tengo, pero no está...
No está integrado en la presentación. Tenía que haberle dado el file del video.
O sea, la liga.
No solamente la liga, sino también
Pues según yo sí los puse. ¿Sí?
ya
comprendo. Muy bien, bueno, lo pueden buscar en YouTube.
Ok.
Bien, y bueno, para cerrar también otro proyecto que se hizo en Tecate, que se está haciendo. Problemas técnicos. Bueno, este es un proyecto que está ahorita en marcha y que se espera que ya esté operando para el siguiente año. Es sobre el proyecto de Energías Sierra Juárez. Bueno, este es como, no sé si un hito o algo que sea bueno, pero el chiste es que se está exportando o se va a exportar electricidad a San Diego. La electricidad se va a generar aquí en México y se va a exportar a San Diego. Bueno, se espera que cuando acabe el proyecto sean 225,000 toneladas de dióxido de carbono las que no se arrojen a la atmósfera por quema de combustibles para la producción de electricidad, y que se inviertan $2,000 millones en total, que pues sí es discutible si se queda aquí o no la inversión, si la energía se va o no a Estados Unidos, si se beneficia a la población mexicana o no, pero bueno, eso es lo que se espera que sea en el año 2015. Y bueno, son 47 aerogeneradores, hasta ahorita se han instalado 20. La capacidad de estos es de 3.3 megawatts. Y bueno, también aquí hay unos datos de que dice que ahorita en México existen 26 parques eólicos en operación, y pues lo que se concluye es que la energía eólica pues sí está teniendo un despunte aquí en Baja California al menos, y que se espera que con las tendencias de la legislación, con la reforma energética, con los problemas ambientales que hay, el cambio climático, vaya a la alza. No solamente esta energía, sino otras más como la geotermia que ya les hablaron, o el aprovechamiento de biomasa también. La solar. Que bueno, la solar sí, también hay una acá en La Paz, acá en Baja California Sur, pero bueno, según ciertas publicaciones que he consultado, es una de las menos eficientes de los paneles solares. Y bueno, eso es todo. Muchas gracias.
Okay, well, thank you very much to all our speakers. Then let's start discussing. Do you have any question? Come on. See, Leslie? Yeah.
Thank you for your presentations. They were awesome. I'm going to speak in Spanish after. So I have a question about your methodology for the, what was it, the phase A, the A component. to the first project and the scale that prioritized international, national components versus a number one to the local and the regional, and how that would affect what is sustainable for who, and who is the priority for the sustainability and the impacts for that type of energy use, which I think correlates with this last point of the energy being exported into the United States into San Diego. So what are the local impacts and who is benefiting from that, either environmental degradation or social impact, and who is benefiting in, like, I would say, a capitalist appropriation to energy that continues to happen. So what I'm trying to unravel, like, what can be done to focus on the local and the regional versus kind of sustaining a capitalist production of energy and using, like, the state as a means for thinking about energy and its use. So I'm going to try and translate that into Spanish. So quería saber la metodología que usaron para el componente A, que da la prioridad al nacional e internacional y da uno al local y al regional. Entonces, ¿cuál es, cómo se dice, el por qué y cuál es la política que invierte más a lo internacional que a lo local? Y cómo se podría ver también la conclusión que dijo que la energía que se está exportando a San Diego, la cuestión de lo local y el impacto a lo local, en lugar de ver quién es que va a beneficiar de este exporto, que serían los estadounidenses, aunque sean personas de color. A lo mejor el impacto regional y local de México va a ser más grave, que sería el privilegio de los Estados Unidos de tener la energía. ¿Me entienden? No sé cómo decirlo más. O sea, ¿cómo podríamos tener un enfoque más en el impacto y menos, diría, capitalista?
Okay, I think that I will give the...
Myself?
Yeah?
Okay.
It's a complicated question because it is not in our hands. It's in the hands of the Federal Commission of Electricity, so they are the decision makers. So if they have, normally they have more sources of energy producing, and the geothermal energy right now is not the main source. So they use other sources, and they prefer to sell the energy to the United States because of the distance and because of the economical benefits. But of course you cannot put in the price, it should be the environmental impacts that it will cause the production of the energy. It could be a good idea to do it, but right now the politicians don't do that. Like, for example, you can think about one time somebody showed me a lamp, and he said to me, okay, this lamp, if you it normally costs like $10, yeah, but if you put the cost with the carbon emissions, with the CO2 emissions, then it will cost like $100, because the materials are brought from Brazil, and then it will be transported by airplane and blah 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 blah. So, but this is just like an idea right now. So maybe Fernando has to say something.
Okay, we found analyzing the RIAM matrix, we found that the scale is it's not sensitive. It's as you said, it's more focused on the international scale, but we found that as a little problem because so many problems are in the local scale. Talking about Cerro Prieto, because of this location, geographical location, some attributes has a major role being international. But if you could move the geothermal power plant, I don't know, 100 miles to the south, the same impacts, the impacts are the same, but the scale will be smaller. It would convert into international, to maybe national, or even regional or local. And what's the logic of that? The environmental issues don't respond to geographical limits, to geographical divisions. That's an argument for us for working on it and to propose an improved matrix that would be more sensitive to the local area. And why these things are focused on the macro scale? One of the factors is because they came from international agreements, as everybody knows, the United Nations, the Royal Report, are all international agreements, and geopolitics considerations, and as that one of the rules of that behavior. But local efforts should be done in that way.
Jocelyn, Luis, do you have something to say? No, go ahead. Luis. Luis.
Bien, bueno, con la aprobación de la reforma, no sé, puedo tal vez no estar muy bien documentado, pero según yo, con la apertura del sector eléctrico, se permitió que, bueno, entre otras cosas, nuevos esquemas de generación y también de venta de electricidad, o al menos a la CFE, pero también se abrió la puerta para importar o para exportar electricidad. Bueno, que si es bueno, que si es malo, pues desafortunadamente ahorita con los esquemas que hay o con los sistemas, creo que la apertura del mercado, de la economía, ya se había hecho desde hace mucho tiempo. Creo que desde que se firmó el Tratado Libre de Comercio, creo que, decir ahorita de que no, pues que no se lleven la electricidad, que se quede aquí, pues sí, tal vez sí sea válido, pero realmente pues el esquema es difícil que se cambie. Tal vez lo que se podría impulsar, que es otra de los aspectos positivos que tiene la generación de electricidad a partir de proyectos eólicos o de granjas solares, es que las personas, al menos las que están muy alejadas del sistema eléctrico, donde no tienen acceso a la electricidad, que se procure su aprovechamiento para esas zonas. Pero pues realmente pues sí es algo discutible, que sí se queda aquel impacto, pero bueno, también se generan empleos también. Tal vez las ganancias se las quede la iniciativa privada y no tanto el propietario del terreno, pero bueno, es lo que lo que puedo decir.
I would like to add something. I belong to the Committee of the Energy from the state of Baja California, and when they presented this Sierra Juarez project to us, it was for them a success. You see, that 100% is for exportation. They saw it like that. And when we asked, well, what about the environmental and social costs? And they were sort of kind of really surprised that we were talking about that and we were not pricing their negotiation. So there is a lot to change in the frame of mind of policymaker and the people that make the decisions in Mexico. That's one thing. The other is that there had been a lot of social conflicts in Oaxaca, where most of the wind powers have been developed so far. I was talking to Dr. Gonzalez that the last time that I was there, I don't know, 3 years ago possibly, it was the installed capacity was about 600 megawatts. 1 year and a half, it was the triple. It was nearly 2,000 megawatts. Can you imagine how much is that? One wind tower has around the capacity of 2 megawatts. So to have 100, you have at least 50. And those are everywhere there. And there have been some social conflicts to such level that at this point, with this energy reform, that it doesn't consider, not yet, the use of renewables. That it has focused a lot on petrol and natural gas. Renewables have not been easily, not easily, they have not been declared. We don't know how things are going to go in that way. And this act of transition is a sort of answer to that, but it has not been really approved, and the instruments to put in place the use of renewables, it has not been done, not yet. It may take a couple of years more, and in that time, the 71% that the wind power was growing per year from 1994 possibly has stopped because investors are waiting. So this Sierra Juarez project, wind farm, is an exception. It has been promised, I think that it was announced in 2012. And I told you, it's for sure, 100% is for exportation, 100%. And all the impacts, the social, maybe not social, because the land is not agricultural land, as is in Oaxaca. That is the main problem in Oaxaca. But in here, let's say that it was not in use, okay, they are not going to have that impact, that social impact, but the environmental impact is there. Not a problem. Okay, but anyway, I hope that all of us answer your question. Una de las cosas que le estaba comentando a Leslie es que la Comisión Estatal de Energía considera un logro el haber logrado la negociación de que 100% de la energía que se está creando en este parque eólico de Sierra Juárez de 47 megas se esté yendo a exportación. Y que este es un gran problema porque los tomadores de decisiones consideran que realmente es un logro el que se cree un campo que dé todo para exportación y que no consideran mucho cuáles son los impactos locales en términos sociales y ambientales, y que habría que cambiar eso, que ha habido muchos conflictos sociales en Oaxaca por el uso de tierra agrícola y que, bueno, es lo que deberíamos cambiar, más o menos resumidamente, en resumidas cuentas fue lo que dije. Any other question, please?
I wanted to ask, because I know that there's a good amount of Chinese companies active in Mexico, and I wanted to ask who's building the generators of wind, especially the solar panels, because China has been heavily investing in renewable energy, and not just for its own use, it's also actively exporting very cheap, competitive solar panels. Entonces, ¿quién son las compañías? ¿Quién son los chinos que construyen esos paneles y esos generadores? ¿Son mexicanos? Eso es mi pregunta.
I don't know about the wind and solar panels. I know about geothermics, and the technology is from Japan mainly. The turbines are coming from Japan. But what I'm sure is not Mexican technology.
As far as I know, in the local case, in the Baja California case, the aero generators are Spanish.
They're Spanish. Spaniards. Yeah.
Well, I don't know for sure, but as far as I had read, there are not a lot of Chinese yet in Mexico.
But so, and the workers building the generators and the panels, they are Mexican, right? Because we're talking about impacts on the local
Well,
population.
okay. The assembly of the wind tower is done by Mexican hands, and the work that is offered to the Mexican workers in the region lasts for 10 to 15 months.
No, but normally the technology is imported, and I think I don't know, the idea that the Mexicans have is that if it's proved in another country and it's working in another country, then we buy that one.
Yeah.
And normally we have the Chinese technology like a low quality level. So I don't think that we already have Chinese technology. Not yet. Yeah, because they are improving. I mean.
Okay, any other question? ¿Alguna otra pregunta? Chicos de la MAIA, adelante, a eso, no se duerman. Axel primero, después Celso, adelante.
I'm going to try to do this in English. I'm not sure, but Dr. Zayre, you said that geothermal energy is not the cleanest of it's not cleaner than other kind of energy. Is that right?
Yes.
I would like to know why. I'm declaring myself completely ignorant on this field.
Because, okay, if you compare, as I said, if you compare hydrocarbons energy production with any other renewable energy, of course they are cleaner. But just focus mainly on the CO2 production. But if you think about the heavy metals that you are extracting from the earth through the steam of the geothermal well, and then you think, okay, you are making a hole in the earth to reach the heat, yeah, to reach the heat, and then you put some groundwater inside, and then you start producing the steam. This steam goes to a turbine, and then you generate to the generator, and then you have the electricity. But what happens with the steam? You condensate the steam, and then you concentrate the water, and then you get a brine, like this is called geothermal brine. And normally, when this heat is coming from the core of the earth, and also is coming sometimes from the radionuclides. In the case of Salton Sea, they have also this contamination, let's say, these contaminants. They have radionuclides also. And then if you combine that and if you concentrate, then you have a pool of heavy metals. If you don't control it well, then you have also infiltration in the groundwater, and then you can have heavy metals in the wells surrounding the area. Then you have hydrogen sulfide, methane, and other gases coming out together with the steam. Those are called non-condensable gases. And then you have noise. And then you have also, it looks not so nice. Subsidence of the land. Because if you are extracting the water, then the land is coming down if you extract a lot. And of course, there are now new technology that they are reinjecting the geothermal fluid into the system, but they are also having lower production of energy because of the heat change. But I think the oldest field is in Italy, and then we have Iceland, and then we have also New Zealand, which have a lot on environmental impact of geothermal energies. The United States, of course, but I have not found many research about environmental issues, because normally they think, is better than hydrocarbons, and we are safe. Yeah, but no, heavy metals is also hard contamination. And even if you have a reservoir very close, like the example I just said, the Salton Sea and Cerro Prieto, you can have huge differences in the concentrations of the elements. Like Cerro Prieto has low arsenic, but for example, Los Humeros in Puebla, they have a lot of borate, and this is not good for the agriculture. They also had an accident, like the population close to this field, they didn't have water. They took the water coming from the plant, and all the plants died, because of course it's not for agriculture or even for drinking or something else.
Celso, por favor.
This issue of geothermal energy is totally new for me. The question is about how much demand will it supply? What is the scope respect to the distribution? What kind of infrastructure is needed to distribute it? And who benefits from the use of this energy?
As what's your name? Luis? Yeah. As Luis said, Mexico has a goal. In 2025, they have to produce certain amount of megawatts from renewable energies. So also I forgot to say to you that in CICESE we have the leadership of a CEMIE. CEMIE is Mexican Center of Energy Innovation, and they will be created 5 of them. 2 are already created, the solar and the wind. We are the leadership of the geothermals, and the oceanic and the biomass are coming. And therefore, we are involved in these big projects. The geothermal energy has a lot of potential in Mexico. They are right now 33 projects going on, looking for the realistic potential calculation, because they have calculated the potential, but they are not accurate. And I think that the CEMIE Sol and the CEMIE Wind, or solar and wind, they are doing the same, or that's what I hope. And with this, you know, all the energy is just the transformation. It can be the heat or normally the heat and the mechanical movement into electricity. So you need the turbine and the generator, and then you produce electricity. And the net is already there, because CFE is the one in charge of that. So you just produce the energy, you put it in the net, and then you supply the electricity. So, Fernando?
Okay. In addition...
wait.
Okay.
Fernando is my technician, researcher assistant. Sorry. It's just a kind of a name problem. And he is...
I think that you know him. He studied MAIA. He finished last year. Yeah.
So now he is working with us in the CEMIE Geo, and he is trying to help me with the social aspects of the environmental sustainability monitoring of 3 sites.
Okay. You talk about the scope. You ask about the scope of the geothermal energy. The thermal energy has one of the biggest potential in the world. Actually, there is less than 1% of the total potential of the thermal power being used by now. And there are some countries that are have benefits of using geothermal power, like Iceland. The 50% of the energy consumed in Iceland is produced by geothermal energy from volcanoes. In numerical sales is 100,000 more, almost 200,000 people. In another important country in geothermal aspects is Salvador, with 25% of the energy production is geothermal. And taking the aspect of as we said before, geothermal energy is not the cleaner option, but is a need in the sense of countries and the world needs to make a diversification of the sources of energy. So oil will not be there forever. Solar energy also contaminated with silicon on the solar panels. Maybe there's no total clean energy in the world. All forms of energy production can produce impacts. And about infrastructure, what infrastructure is needed to explode the geothermal energy? The infrastructure will depend on the site, on the geothermal field or the geothermal resource. Like it's not the same dry rocks or aquifers or volcanoes. It will be depend on the site. And who's
no, but normally you have the same infrastructure. You need the turbine and the generator and the cooling towers.
That's a basic scheme, but the facility will depend on.
Okay, if I can say something, yes, my geothermal colleagues. Here in Baja California, in 1991, 71% of the production of electricity came from geothermal sources, Cerro Prieto mainly. Nowadays, 2015, only 24% come from that source. And it's not only because it has reduced in plate, no, it has reduced, of course it has reduced its capacity, and because it has not been exploited rightly. That is important. We have a huge potential, but as well, the investment has gone in another direction. In this case, in Baja California, went to natural gas for obvious reasons, and Sempra Energy and the rest of that. But it's important to say, I mean, of course, we are in a sort of fashion now in renewables, and of course, there is a legislation that is pushing to the use of renewables greatly per year, 35% to 2035, yes. But honestly, I don't see how that goal is going to be reached. Anyway, any other question? No? Okay, well, saying that, we are going to end this session here, and we invite all of you to go outside to see the landscape, to see the sea, to have some bite of something nicely and drink something. Carlos?
Kyle, would you like to explain us what is this for? And just to let us
so we brought a couple. We were asked by the director of the master's program at SCRIPS, the Oceanographic Policy Master's Program, to bring some information about the program. They're looking very hard right now to try and expand their amount of Mexican students that they have coming into their programs. This might be, if any of you guys are thinking, if you guys are already in a master's program right now, if you're thinking about something on the U.S. side, this might be something interesting to check out at least. Part of it is through Octavio Alberto, who works in Cabo Pulmo, and who
Felipe has been talking to recently, they really want to expand the regional impact of their program to include Baja California. So if you know anyone who is interested in those kinds of things, then you should have them check out some of the information that we brought today. If you have questions about it, you can talk to us or to especially to the Scripps students from MAS who will be at the UC San Diego meetings more often. But you're all welcome to check that out.
Thank you, Guy.
Thank you.
Okay,
very
so
much.
we have something refreshment there and some welcome and vamos para allá.
Thank you.